Hello, I'm Chris Hall, and today I'd like to discuss some of the technologies being used in high schools to engage learners within the mathematics curriculum. I will be basing my presentation on content from the following sources: a YouTube video, New Maths Technology in the Classroom, which shows the use of maths-based technology in an English high school, and the reactions of teachers and students. Kozek-Krizan's 2005 article in the Micromath Journal, How Mathematics Teachers' Own Learning Experiences with ICT Affects Their Classroom Practice, and the Geometer's Sketchpad Resource Centre website. Video, New Maths Technology in the Classroom, visits Tambridge House School in Sussex, where teachers aim to make maths more stimulating by integrating various forms of technology into their lessons. We are shown how an interactive number line, a graphical plotter, geometric analysis software, and graphic calculators allowed the teachers to directly involve the students in the learning activities. In each session, it was clear that the technology encouraged students to participate in the lesson and to explore and investigate the topic rather than being passively fed information. This was particularly evident in the third example, where an apparently dull classroom lesson is transformed into an interactive experience in the computer lab using the geometric software. From the teacher's perspective, they found that by giving the students the opportunity to trial and explore answers in front of the class, it allowed them to ask more questions of the class and generate a better understanding of the topic. They also found that retention was improved when revising the topic at the start of the next class. A major benefit of the use of technology was evident during the fourth session, where students were asked to plot lines on a graph to form squares using their graphical calculators. The teacher started by demonstrating the functions of the calculator using an interactive display. This allowed the students to follow along on their own device, and because the whole class had the same calculator, ensured that they had the basic knowledge to be able to complete the task. Interestingly, I observed a lesson during my recent practicum in which the teacher demonstrated the calculator's functions using the interactive display. This was less successful, primarily, I believe, because the students did not all have the same device, and those who did not were de facto excluded from that part of the lesson. The other benefit from this form of technology was that each student had a level of personal control over the task, in that they could experiment on their own device and didn't have to share their answers within their group or to the rest of the class until they were happy with their solution. In researching her article, Kozek-Krizan contacted 7 maths teachers with varying experience of the profession and indeed of ICT, and followed their journey using different maths packages in their lessons over 3 years. Their schools have been well resourced with the technology thanks in part to a local government initiative funding the purchase of the necessary licenses. The teachers had all received basic training on the applications, in this case Omnigraph, Autograph and the Geometer's Sketchpad, but Krizan found that they all spent much more time becoming familiar with the applications and their capabilities. This was important to them, she reports, because it allowed them to link the applications to the various maths topics and gave them ideas where the technology could be applied in the lesson. To this end, the teachers' prior knowledge and experience of ICT in general was key to their understanding of the applications. Those that had some previous exposure to one application naturally favoured that application over the others. The head of maths at Tambridge House School identified that teachers were initially nervous of using the technology, particularly in front of their students. Krizan and other researchers have found that having a belief in the technology is of greater importance than having prior knowledge of it. Those teachers that embrace the potential of an application will invest the effort in familiarising themselves with its functions and developing learning activities around it. Teachers, while learning the applications, saw potential in connecting with learners in different ways to a more traditional teaching approach. One identified being able to visually connect the topic to the real world through use of the software, which made more sense to him than a rigorous mathematical proof, for example. Another understood how ICT could help him show the link between different topics and promote the wider picture of mathematics. One of the applications used by the teachers in the study is the Geometer's Sketchpad. This piece of software can trace its roots back to the 1980s. According to the Geometer's Sketchpad Resource Centre website, a research project at Swarthmore College, Pennsylvania, aimed to harness technology to help teach geometry. Nicholas Jakiev developed the first version of the Geometer's Sketchpad, and his techniques for manipulating diagrams were seen as having great potential in the field of education. The first commercial version of the software was released in 1991 and has been updated several times since. They're currently on version 5, to become one of the world's leading tools in maths classrooms, not only in high schools, but also colleges, universities and beyond. Sketchpad is available across multiple platforms: Microsoft Windows, Apple Macintosh, and iPad. The Resource Centre contains a huge library of activities, lesson ideas, sketches, and other resources for users and educators alike. The Getting Started section contains the useful advice: don't worry too much about becoming an expert before sharing it with your students. The software is designed to be explored either by using one of the many pre-planned activities which contain teaching notes, student worksheets, and the necessary sketches, or simply by trial and error. It's claimed that by sharing what they learn, students will quickly become proficient. And this claim is backed up by the findings of Crisan and the experiences of Tambridge House School. Under Instructor Resources, users or potential users can download a workshop guide which contains a number of guided activities in the field of geometry, algebra, calculus and trigonometry. These walk the user through basic functions and operations, such as constructing objects using a compass and straight edge, dragging objects to see how properties change, drawing graphs with variable parameters, transformations and tilings, and so on. Clearly, there is much potential for the use of technology in teaching high school maths, yet it appears to be still in its infancy, particularly in Australian schools. I've already touched on the fear of change, of doing something different and unfamiliar that may be preventing teachers from embracing ICT in the classroom, though that can be overcome with a positive attitude towards the technology. The biggest barrier is likely to be cost. It was noted that the schools in Crisan's article, and this was also the case for Tambridge House School, receive funding from their local education authorities to purchase equipment and software. At a time when schools' budgets are already stretched to the limit, it's going to take considerable vision and investment for the positive changes that we have seen in these examples to become mainstream. I'm convinced that technology has a major role to play in maths education, and I look forward to using some of these techniques in my classroom in the future.